this video, let's talk about a concept called RAG, R-A-G, and what's the difference between RAG and Agentic AI, and which one you should use. So let me break this down for you technically, but very simply. Let's start with the core problem that both of these technologies, RAG and Agentic AI, are trying to solve. Imagine you have a large language model like ChatGPT or Claude. It's smart, but it has a critical limitation. Its knowledge has an expiration date. Let's say it was trained on data up until a certain point, let's say June 2025. So if I ask it a question about what happened in February 2026, it has no idea. It will either give you outdated information or it will just hallucinate an answer, come up with something that doesn't exist. Second problem is even for things it does know, it doesn't have access to your private data, like custom information. I cannot ask ChatGPT what was my company's revenue last quarter because it has no way to access my internal financial systems to get that information. And there is a third problem, which is the model can't take actions. It can only generate text. If I want it to actually book a flight or update a database or send an email, it just sits there and talks about what I should do to execute those actions. So it can just give me suggestions of how to do that myself. So here's the question. How do we solve these three problems? How do we make an AI system that has fresh, accurate, relevant information and can actually take actions? That's where RAG and Agentic AI come in. But they solve these problems in very different ways. Let's start with RAG. RAG stands for Retrieval-Augmented Generation. It sounds very confusing, but let me break that down in simple terms. Think of it like this. Imagine you are a student taking an exam, and the teacher allows you to bring notes with you. You cannot memorize everything, so you just bring your notes. And whenever the teacher asks a question, you quickly flip through your notes, find the relevant information, and then write your answer based on what you found, instead of what you have memorized. That's exactly what RAG does. So here's the flow. Step one, you have the preparation phase. You have documents, data, or knowledge that you want to make available to the AI so you can ask questions about it. This could be your company's policies, a product documentation, customer data, research papers, whatever which is internal custom information of your company. These documents do not go directly into the AI's training. Instead, you convert them into what's called embeddings or vector embeddings. Now, again, what is that? Think of vector embeddings as a numeric representation of text or mathematical representation of meaning a text has. So every sentence, every paragraph gets converted into a vector, which is basically a list of numbers that represents what the text means. Because we understand text, computers understand numbers. So we take a sentence and we convert it into numbers that a computer will read. And then we store all these embeddings in a special database called a vector database. Examples of vector databases like Pinecone and so on. The important thing here is the database, the vector database, is optimized for finding similar vectors very quickly, which again means you have phrases and texts which all have numeric representations or vector representations. And this database basically has a feature to allow to look up similar texts and phrases based on those vectors or numbers by comparing them together mathematically. So that's the preparation phase where you take those documents and you convert them into vector embeddings inside a vector database. The step two is when a user asks a question. So everything is prepared, everything is inside this database, and now you can ask questions based on the information that's stored in there, which are your company documents, any custom information, or knowledge base. And the same way as with AI chat, you basically connect your AI chat to this database to look up the information whenever you ask it something about your company internal stuff. right? And then you can provide this chat either to your employees, internally in the company, or even your customers, like a chatbot on your website, for example. So let's say you do that and you have a chatbot on your website, and a customer comes along and asks this AI, what's your return policy for electronics? And let's say you have an online store for electronics that you are selling, and you have an AI chatbot on your website that is connected to the vector database that has all the information about your company policies, your products, all your electronics that you are selling. And a customer asks this AI chatbot, what's your return policy for electronics? So this is what happens with REG system. The system takes that question and converts it into an embedding using the same method. So first, in the step 1, it took the documents and all this information and turned that into embedding. Now it takes the question that the customer is asking and is converting it into vector embedding to represent the text the customer asked into the vector. So now your question is also a vector of numbers. Then the system searches the vector database and says, find me the embeddings that are most similar to this question. And this is called a semantic search. So it's not keyword matching, it's meaning matching. So how close is the meaning of this sentence to the meaning of sentences or phrases I have in the database? Trying to match exact words like apple to apple, MacBook to MacBook. The semantic or meaning matching is when you know that a computer, a laptop, a MacBook, they're all similar to the word MacBook, for example. So when that lookup happens, the database returns the top results, which are the most similar to that question. So maybe it returns 3 documents about your return policy in this case. And these documents are the most relevant to the question based on the meaning, not just keywords. Then comes step 3, which is generation. Now here's the key part. The system takes the question and the retrieved documents and feeds them together to the language model. Here's a question. Here are the relevant documents. Based only on those documents, answer the question. The language model then generates an answer based on that specific information from the database. It's not making things up. It's basing its answers on real data from your documents. And this solves 2 of our 3 problems. First of all, fresh information problem, because you control the documents in your vector database. You can update them whenever you want. So you can always have fresh information for your AI to consume or base its answers on. And the second is private data, because you're hosting your own vector database. Your company's data never leaves your systems. So it's available to your language model, but it's still your custom data that only you have access to. However, it does not solve the third problem, which is that AI still cannot take actions. It still only generates text based on documents. Now, the difference is that it's not just generic AI knowledge, it's your custom, very individualized, your company-specific knowledge that you added on top of the trained data. But it's still generative AI. It cannot take action on your behalf. And that's exactly where the concept of agentic AI comes in. So all of this that we talked about till now is reg or generation. So you're retrieving additional data from your custom data source, your own vector database, and you're adding that in addition to the LLM's training data as the base for the answers it should give on questions. And generate replies on. However, if we're talking about AI taking action on your behalf, that's where the concept of agentic AI comes in. So let's talk about agentic AI now, which is fundamentally different from reg. Agentic AI is about making the AI system autonomous. An agent is something that acts on your behalf independently without waiting for approval on every single step and telling it, now go do this, now go do that. It basically gets the task and it knows how to execute it in which order based on the tools it has available. So let's talk about that. Think of it this way. Imagine you hire an assistant, and let's say you want your assistant to book a flight for you. You don't tell your assistant, open Google browser, search prices, then compare them, and then book this one. First of all, that would take forever, but second of all, it's extremely inefficient. Instead, you would say, book me a flight, and these are like 2-3 criteria I need you to fulfill. You say, book me a flight to Berlin next Friday, preferably in the morning. This is the maximum budget. That's it. And your assistant figures out all the steps independently to achieve that final outcome. That's exactly how Agentic AI works. And here's what makes an agent actually work. The first component is the reasoning engine. At the heart of the Agentic AI is, again, a language model, but it's being used differently now. Instead of just generating an answer, it's reasoning about the goal. It's thinking, what do I need to do to achieve this final outcome? What sequence of steps makes sense, in which order? The second element is tools and APIs, and this is probably the most important differentiator here. The agent has access to tools, or you give it access to any tools that you want it to use. And these are not just documents or information, these are actual functions that it can call on your behalf. For example, it could be access to your Google Calendar. It could be access to a database query tool where you say, search our customer database for this specific information. It could be an API integration. You can tell it, call Stripe API to check payment status. Or the most classical one, or most common one, is a web search tool. Look up real-time flight prices for this and this date. Or an action tool like send an email. Or book a call with my marketing employee and add it to my calendar. So now it has the reasoning logic and it has access to the tools that you give it access to. And the third component is the loop. So here's how it works. The user of the agent, like you, gives an agent a goal. For example, you can say, process this customer refund request. The agent then thinks, okay, to process a refund, I need to first look up the customer's order, check the refund policy, verify that they are within the return window, and if they are, then initiate the refund. So that's the reasoning cycle. So this is the steps I need to execute in this order. That's the agent thinking through steps of how to achieve that goal. Once it has decided the steps, the agent then calls the first tool, get customer order details. It receives the data back. The agent processes the data, extracts the information, decides the next step. Okay, the order is 3 days old. Let me check the policy. The agent then calls the second tool, check refund policy for this product type. It receives the policy back. The agent then actually reasons. So policy says 30 days. The order is 3 days old. They qualify. Now initiate the refund, which means the agent now calls the action tool, process refund, and it happens. So this whole loop happens automatically. The agent is making decisions, taking actions, and handling problems independently. And tying it back to our initial example, this actually solves all three problems. Fresh information, agents can search the web in real time, or it can also search your database in real time. The second is private data, because agents can access your internal APIs and databases, your custom individual company-specific data. And third, take actions. So agents can actually execute changes in your systems by calling different functions of those tools. So to make this click even better, let's compare these two concepts side by side. Because understanding the differences is crucial, because you might need one or both or neither depending on your use case. The first one is the purpose. So RAG is for answering questions based on internal company or custom documents that are not public knowledge, which means they're not part of the training data. So it's retrieval in addition to what AI or LLMs already have from the training data, and then generating that answer by combining those two. The Agentic AI the purpose of it is for completing tasks and achieving goals independently. So it's reasoning, then acting, not just generating text. The second difference is the data source. So RAG works with static or semi-static documents, because you embed them once, you store them in the vector database, and you query them. Agentic AI works with dynamic real-time systems. So it connects to live APIs, databases, different tools to take action in real-time dynamic environment. The third difference is the complexity of tasks. RAG handles more simple, like single-step tasks, right? Find the answer to this question in my documents. For example, you're doing employee onboarding in your company, and all your company intelligence and knowledge is embedded, and that employee basically can query AI using RAG system, your company internal AI, to get all the information and context it needs to get onboarded and start working and being productive. While agentic AI handles complex multi-step tasks, such as complete this workflow that requires making multiple decisions and taking multiple actions. Could be booking a flight and then putting all the data in your calendar, then maybe booking an Uber to get you to the airport in right time. Or it could be coding a complete website and deploying it to the production environment, buying a domain name, connecting it to your website, and publishing it to the end users. So basically, complete workflows that require multiple steps and decision-making throughout. And the final difference is real-time requirement. RAG is fine for questions where the answer does not change minute to minute, right? It's more static or semi-static. As I said, we take all those documents, we embed it, we make those updates in the document, in the database, but they don't change daily. Whereas agentic AI is necessary when the answer depends on real-time information or when you need to execute actions immediately in real time again. And finally, another difference is cost and complexity. So RAG is simpler to implement. You basically need a vector database, an embedding model, and a language model, and there are even abstractions for that, like LangChain. And that's it. You have lower cost, lower complexity. Agentic AI is more complex. You need tool definitions, API integrations, you need error handling when something goes wrong, basically a more sophisticated reasoning loop. And you have higher costs because you're making more API calls, but also it's more powerful. So to easily summarize this, use RAG when you have a knowledge base that does not change constantly, like your company policies, product documentation, your training materials. You want to reduce hallucinations by grounding answers in specific documents. So your use case is read-only. You're just answering questions. You're not taking actions. And maybe cost is a concern because RAG is cheaper since you're doing fewer API calls. And some of the real-world examples for this would be, let's say, a bank using RAG to answer customer questions about the loan products. The loan terms are documented, they change maybe monthly. You update the vector database monthly, and customers get accurate answers. Use agentic AI when you need to complete multi-step workflows, and the task requires real-time information, or when you need a system to actually execute actions, not just talk about them or give you replies to your questions, or even when the steps are not fully predictable, where the agent needs to reason and adapt. An example for that would be coding a website and then collecting user feedback and using AI to adjust the website and features based on that user feedback. So that means you don't know exactly what the task would be at the beginning or from the start, because the agent will need to adjust to the real-time requirements of users. So you see that agentic AI use cases are actually more complex and more diverse. A simple real-world example would be, let's say, an e-commerce company that uses agents to handle refunds. The agent checks the order, checks the policy, verifies that it qualifies, processes the refund, and sends a confirmation per email, all automatically, independently. But here's an interesting part where you can use both when you need to complete a task that requires both understanding documents and taking actions. So for example, you can create a customer support AI agent that first retrieves relevant policies from your knowledge base using RAG, and then uses that information as context to make decisions and take actions, like updating a ticket or triggering a refund or sending an email back saying you're not eligible for refund, or I just process the refund, you will get it in 2-3 days. So here's the key takeaway from this. Rec and Agentic AI are not direct alternatives to each other. They're actually complementary technologies solving different problems. And Rec is about making AI systems smarter with more information by giving them access to custom, non-public information it doesn't already have in its training data. Whereas Agentic AI is about making AI systems autonomous by giving them the ability to act independently, to do things in the real world. And in the future, we will see more systems combining both of these. An agent that retrieves relevant documents to inform its decisions and then take actions based on those documents or those information. And for you, this means if you're building AI systems, understand what problem you're solving. Are you trying to answer questions better? Then use Rec. Are you trying to automate workflows? Then use Agentic AI. If you need both, then you will build both and combine them together. So I hope I was able to demystify these concepts for you and helped you clarify these terms. If I did, let me know what was the most important information that you got from this video. And with that, thanks for watching, and I'll see you in the next video.